Hi everybody, this is Mrs. Lehman from Math with Mrs. Lehman, and I'm here today with my 4th period class. Hi! I hope everyone's having a fabulous Monday. Happy spring. We are going to find the perimeter and area of this weird shape on the coordinate plane. So, this was page 38 of your module. The first step to finding perimeter is understanding that perimeter means the distance around perimeter is the distance around the outside of a shape. So, for example, in somebody's yard, they might be buying fencing. You know, they're not going to put fencing over the area of their yard. They're just going to surround their yard with the fencing. The trim around windows and doors and that kind of thing, that would be perimeter because it's going around the entire shape. Or if you look at the bottom of like our school wall, we have this edging stuff at the bottom that goes around the entire perimeter of the room. Okay, so those are things that you would use perimeter for. In this case, we have a side length of 11, 13, this side's 13, 4 here, 4 here, 4 here, 4 here, and 3 up here. So what you need to do is add these all together and be careful with your calculations so that you get the right answer. So I'm going to do 13 plus 13. That gives me 26. I'm going to add this 11 to it. That's going to give me 37. And then I still have 4 of these 4s up top to deal with. So that's 16. I'm going to add that and get 13. Carry the 1. I'm going to get 53. And then I still have 3 more that I have to add on. So I'm going to get a total distance around the outside of 56 units. So that is the perimeter. Alright, that's just measured in units. Any questions on that? Alright, your second job was to find the area. So again, when you're showing your work, you're really telling a story of where your mind went and taking the person looking at that work through a little bit of a journey of how to solve this. So the quickest way to solve this one is to take the area of this entire rectangle, all right, and then carve out the piece you don't need. So I don't want this red section, this red rectangle in there. So what I'm going to do is subtract that out. Some kids have approached this differently throughout the day and will chop it off here, chop it there, and find the area of those 3 rectangles and add them together. You know, tomato, tomato, it does not matter. You can choose what works best for you, but honestly, the one that requires less work is to encase it in this case and subtract out the red, which I colored in red, that red section. Okay? So, if I'm finding area of that first shape, the big rectangle, I need the formula. So the area equals length times width. I have 13 times 11. When you multiply that out, you get 143 square units, or units squared. All right? But I'm not done. We have another one to figure out. Area equals length times width. You're going to take out that 4 by 4 square, and you are going to get 16 units squared. Now this is where you have to, again, remember what you're doing. You're not adding these two together. It's like the difference between making a snowman and an ice sculpture, right? With a snowman, you add all the pieces together to make your snowman. With an ice sculpture, you're going to start with that block, and then you're going to carve out the pieces you don't want. And that's the method we're going to do here. So we're going to subtract 16 from 143. And you should get, when you are done, 127 units squared. All right? Any questions on that? Yes? Yes. Now, some people, Madison's bringing up another way. And again, there are multiple ways to approach problems a lot of times. So what you could also do is split it into rectangles like this, and then you'd have a 4 by 13 rectangle, a 3 by 13 rectangle, and a 4 by 9 rectangle that you would all have to calculate the area of and add them together. Now some kids said, well, couldn't you just count the boxes? Well, you could, but as soon as you have a diagonal line in there, you'd be done. All right, so let's say it was like that shape, you know, you'd have to add that triangle on there too. You can't just count those because, you know, these are partial ones and you're not going to eyeball that correctly. Okay? Any questions on that? Did you get the right answer when you did it your way? Yep, there's more than one way to do this. And again, if you did it all correctly, it should come out, regardless of which method, as 127 units squared. Your homework was on page 37. Let me get to that. Oh, here's our math joke of the day before we get to that. Here's a pentagon, a hexagon, and Oregon. You don't get it? So these are polygons that you would see in the coordinate plane. These are polygons. This is Oregon. Yeah, some people aren't getting it. They don't think it's that funny. But so I have a quick joke for you all. What did the mathematician say when he lost his parrot? Polygon. Oh boy. You didn't know that you tuned in for such great jokes on Math with Mrs. Lehman. It's just a little bonus that I provide to my viewers, you know, so I hope you're enjoying them. Anyway, I don't know what to say. Alright, so drawing polygons on the coordinate plane. You had two different shapes here. So shape number 1 is pretty easy. You know, you have a rectangle and a triangle. Alright, so I want you to get out your homework. I'm going to take a quick glance at that, and then I'll come back to our viewers and go over this quick. Alright, so the first step whenever you're finding the area of something is to write the formula. So in this case, I'm going to do, I'll do this rectangle first and that triangle second. So area of a rectangle is length times width. And the length there is 6 and the width is 2. So you multiply those two and you're going to get 12 units squared. Then for shape number 2, which is a triangle, you're going to get area equals base times height divided by 2. You're going to get a base of 4, a height of 2, or vice versa. It does not matter. You're going to get 8 divided by 2, which is 4 units squared. So you want to put these two pieces together. So mathematically we are adding. You're going to get 16 units squared. Raise your hand if you got 16 units squared. All right, very nicely done. Again, your work is like gold, so make sure you are putting your formula first, you're plugging in the amount of units second, and then you're doing whatever calculations are needed and labeling your answer. Number 2. So shape number 2, I'm going to start this up here. That looks kind of weird. Okay, so I'm going to do this. I guess I'll start it down here so it doesn't look like I'm doing that next to one. Alright, so in this case, if you try to chop this up, it's not going to work well for you because it's really hard to see exactly where things intersect there. You're going to want to encase this one. And we don't have a nice right angle that we know of. So we're going to encase this in a box. We are going to then take out, or carve out, as I would say with the ice sculpture analogy, the pieces we don't need. So we want to essentially find the area of these 3 triangles right here and subtract that from the area of the entire rectangle. Alright, so we've got 1, 2, 3 here, we've got 3 here, and that's 7 across, right? 1, 2, 3, 4, 5, 6. It's kind of hard to see here. That is 6 up here, and that is 7 here. So this is made up of 1 unit and 6 units. Does that make sense to everybody? Essentially, it's a 6 by 7 rectangle. Right? So the area of that rectangle, length times width, you're going to get 6 times 7. You're going to get 42 units squared. Alright, and then let's do triangle 1, which is base times height divided by 2. Area equals 3 times 6 divided by 2, and that's going to give you 18 divided by 2, which is 9 units squared. Alright, triangle number 2, you're going to again have base times height divided by 2. You're going to get 3 times 7 divided by 2, you're going to get 21 divided by 2, which is 10.5 units squared. And then lastly, for shapes on there, we have the area of the third triangle, which is base times height, divided by 2. We're going to get 6 times 1 divided by 2. You're going to get 6 divided by 2, which is 3 units squared. Now, what do I do with these 3 shapes? Add them together. Good. So you're going to take 9 plus 10 is going to be 19.5 plus 3 is going to be 22.5 units. Now, that's not your answer. That is just the total area of these 3 things. We want to subtract those out of our entire shape, which was 42, and then you take away 22.5, you are going to get 19.5 or 19 5/10 units squared. All right, does that make sense to everyone? Any other questions on that? All right, again, show your work step by step. You really want to lay it out carefully because it doesn't take a lot of, you could make a mistake in one of the triangles and then you're going to get the wrong answer. You know what I'm saying? So, step by step. You're in 6th grade, there's going to be multiple steps to each problem. The days of one-step problems are pretty well over. So, as you get older, you have more responsibilities in life and in math, and one of those is more steps in your math problems. Anyway, we are going to move on to finding the volume of rectangular prism. So a rectangular prism is simply a rectangle that has some height to it, okay? So there are 2 formulas that you need to know, all right? Volume equals, what am I doing? Length times width times height, and because they're variables, I can just put those all together, and that indicates that they are being multiplied. So length times width times height. So I'm going to show the kids right now a Kleenex box. It's pretty fancy. I'm not sure if you have one at home. But if you look at the bottom of that, right, that's a rectangle. It has a rectangular base. And you take the length and the width, and you would get the area, right? So another way of saying this, if we look at this right here, that's the area, isn't it? So we could also say that volume equals the base with a capital B. That means the area of the base times the height. Now notice it's not a lowercase b like we would use for our triangles or parallelograms. This is a capital B, indicating that the area has already been calculated for you. So this we are going to put an arrow to and say area of the base, of the rectangular base. All right. If it were a triangular prism, we would cut it in 2, but right now we're just dealing with rectangular prisms. Okay, and that again means like a box. When we find perimeter, we're just measuring the distance around the outside of something. When we find area, we are figuring out how many square units it would take to cover that that shape, that flat shape. Now we're taking it to a 3rd dimension, where, it sounds fancy, doesn't it? We're taking it to the 3rd dimension, kids, and that is where we're figuring out how much capacity or how much space something has, okay? So think of like boxes, think of like a refrigerator, think of, maybe like a storage tote, all those types of things. You're going to calculate the volume of how much can it hold, okay? So what's its capacity? What's its volume? So we are going to look at the opening exercise where we are given 2 rectangular solids here, rectangular prisms, and we are going to find the volume. So everybody write volume equals length times width times height. And what would we plug in for numbers here? Caleb? 10 times 4 times 6 is correct. So the volume equals 10 times 4 times 6. So this is 24 times 10, so 240 inches cubed, actually. So it's cubic inches because we're multiplying inches times inches times inches. So that's saying how many of these 1 inch by 1 inch by 1 inch cubes would fit into that rectangular prism. All right, how many would it hold? All right, so how many would that hold, Genevieve? Very good, 240. That would be its capacity. That's how many it would hold. So now that you're in 6th grade, they aren't asking you as much of what's the volume. They'll try to word it in a tricky way, and they'll say, how many 1 inch by 1 inch by 1 inch cubes will it hold? And you'll go, I don't know what it's asking, even though you can calculate volume just fine. So I just want to make sure you're aware of that. It means how many 1 inch by 1 inch by 1 inch cubes it contains. All right, so let's do this one. Why don't you guys do this one on your own? First, write the formula for volume. Volume equals length times width times height. Go ahead and do that. I'm going to pause the video and check some kids' work. I'll see you in a sec. All right, everyone did a great job with this one. They did 8. Ugh, I always do that. Hold on a second. Make sure I have it on. Yeah, so, whoops. Why did it do that to me? All right, so you got to plug in 8 times 5 times 12. When I look at this, 5 times 12 is 60. 6 times 8, I know it's 48. Add that 0 to the end, and you're going to get 480 inches cubed. So who can tell me how many 1 inch cubes could this shape on the right hold? How many 1 inch cubes could this hold? Everyone should have their hand up right now. It's an easy question. How many 1 inch cubes would it hold, LJ?
480.
480, very good. So the volume is how many cubic units it would hold. All right? Now, who can tell me which one's bigger, the one on the right or the left? Caleb.
Right?
On the right, very good. So this one here is bigger. How much bigger was the question? How much bigger is that one?
240.
240 inches
Cube.
You might see cubic inches as well. All right, nice job, everybody. Let's move down here to, we're going to actually skip this one. So we're going to go to the next page. This one says you're filling it with dice that are 1/2, excuse me, by 1/2 by 1/2. And there's a trick to that. All right, so I will show you tomorrow. So please be sure to stay tuned in for tomorrow's Math with Mrs. Lehman lesson, because I will show you all that magic. Let's go to the next page, which would be page 40, where you have 2 rectangular prisms here with fractional edge lengths. Okay? So, let's write our formula. Excuse me. We're going to save all the funny business of finding out how many 1/4 inch cubes go into it till tomorrow. We have to find the volume first anyway, so we're going to practice. So, we'd have 1/2 times 1 times 3 3/4. Now, I don't know about you, but I'm not going to worry about that times 1 business again, because if you multiply anything times 1, you get the same answer. So we're going to leave that out. What we need to do is turn these improper fractions, or I'm sorry, these mixed numbers into improper fractions. So who can tell me what 1 1/2 would be? Not everyone at once, please. I mean, I can only call on one kid. All right, I guess, I hate to call on the same kid twice, but here we go. Caleb.
1
1/2 would be how many halves?
3 halves.
3 halves, very good. So what you do is you multiply the denominator times the whole number, add the numerator. That's going to give you 3. Keep the same denominator of 2. Again, I'm leaving off that 1 business. All right, 4 times 3 is 12. 12 plus 3 is 15. 4. So you're going to get 45 eighths. All right, 45 eighths. When you're multiplying fractions, you just multiply straight across the top and bottom. So to turn that into a mixed number, you're going to take 45 and divide it by 8. You're going to get 5 as a whole number. All right, and then you're going to get, that's going to give you 40. You're going to have 5 left over out of 8. So 5 and 5 eighths is our answer. But what do we label this answer with, everybody?
Cubed.
Being cubed, yes, inches cubed. All right. I was writing area earlier today because we have been doing area for so long. It was like stuck in my brain. But anyway, this is volume, so that's cubic. 5 and 5/8 cubic inches would go into this. So if I had 1 inch cubes, 5 and 5/8 of them would be what I would need to fill that up. Okay, we're going to do this next example. We're going to calculate the volume. We're going to calculate the volume. All right, let's see. The volume, I should say. There we go. All right, so volume equals length times width times height. Kind of rushing through this because we're going to run out of time. 5 1/3 times 2/3 times 1 1/3. Again, we've got to turn these into numbers we can work with. So you're going to do 3 times 5, which is what?
16.
15 plus 1 is 16. So 16/3 times 2/3. We don't have to do anything with that one. And then 1 1/3 would be 4/3, right? So this is a lot of fun multiplying. I'm going to use a calculator just for time's sake. So what you're going to do is you're going to have 16 times 2 is 32. So 32 times 4 is 128. And then 3 times 3 times 3 is what? 27. It's not 9. It's 27. We're multiplying. So 128 divided by 27 is going to give you 4 as a whole number. And if you multiply 4 times 27, you're going to get 108. So that means we're still missing 20. We'd have 20 left over, I should say, out of 27. So 4 and 20 27ths, and what unit would that be? Centimeters cubed. Your homework tonight on page 41 for my first, second, and third periods class. I originally said 47, so please take note it is page 41 for your homework tonight. You are going to find the volume of these two rectangular prisms. So your job will be to turn these numbers into improper fractions. Obviously, you're going to have your volume formula, length times width times height. You're going to plug in those numbers, then you're going to plug it in with the improper fraction version. You're going to multiply, and then turn it back into a mixed number. All right? And you're going to label it centimeters cubed and inches cubed for the second example. Any questions on what the expectation is tonight for homework? All right, I'm going to give you a few minutes to get started. I'd like to thank you for watching Math with Mrs. Lehman. Have a great day.